Now, project evaluation and review technique, PERT. In the previous lessons, we have completed the CPM, some illustrations we had taken there. Now, PERT. This technique, unlike CPM, takes into account the uncertainty of the project durations. In the CPM, we are given the definite times. Here we are given different, that is, we have to estimate the time uncertainty of the project durations. We have three different times we have. So we have to find out the estimation of duration. If the duration of activities in a project is uncertain, then activity scheduling calculation done using the expected value of the duration. So however, such expected duration estimate may not give an accurate answer. Thus, rather than estimating directly the expected completion time of an activity, three values are considered. From these, a single value is estimated for future consideration. This is called the three-time estimates in PERT. What are the three times we have? Optimistic time estimate, TO, T naught or A. It can be denoted by T naught or A. Is the duration of any activity when everything goes on well. So during the project, that is, laborers are available and come in time, and machines are working properly, money is available whenever needed, there is no scarcity of raw material needed, and so on. So that means, so then the particular project's estimated time is T naught or A. Pessimistic time estimate, TP or B, it is denoted by TP or B, is the duration of activity when almost everything goes against our will, and a lot of difficulties are faced while doing a project. So at that time, what is the duration we have to calculate? So most likely time estimate, that is TM or M, is the duration of activity when something go on well, some things go on well, and something go wrong while doing a project. Okay, something go on well and something go wrong while doing a project. Two main assumptions made in PERT. What are the assumptions? The activity durations are independent. The durations are independent of each other. That is, the time required to complete an activity will have no bearing on completion of time of any other activity of the project. Or the activity durations follow beta distribution, that is normal distribution. So beta distribution is probability distribution with the density function k of t minus a whole to the power alpha, and b to the power of b minus t of beta whole to the power beta, with the mean t is equal to 1 by 3 of 2tm plus half of t naught plus tp, and the standard deviation sigma t is equal to Tp minus T naught whole divided by 6. Procedure. First, what we have to do in the PERT, draw the project diagram as usual. So how we drew the project diagram, that is a network diagram for the CPM. Similarly, same procedure you have to adopt here. Only the time estimates will be changed here. Compute the expected duration of each activity, that is time durations. Different times are given. Optimistic, most likely, and pessimistic are given. We are converting these three estimates into single value, single time period, that is estimated single time. So T naught plus 4Tm plus Tp whole divided by 6. Compute the expected variance, that is sigma square of each activity. So compute the earliest start, earliest to finish, latest start, latest to finish, and total float of each activity. We have already calculated TES, that is TL values, TF, TE values, TL values. Okay. Then determine the critical path and identify critical activities. Means what is the critical path where the TL values, TE values are same, we cannot draw. Those are called, that is the critical path. Those activities are called critical activities. So compute the expected variance of the project length. This is also called as variance of critical path, sigma c square, which is the sum of the variances of the critical activities. This will give you the project's length. Okay. Compute the expected standard deviation of a project's length, sigma c, and calculate the standard normal deviate, that is TS minus TE divided by sigma C, where TS stands for specified or scheduled time to complete the project. T is normal expected duration or duration of the project. Sigma C, expected standard deviation of the project length.